titrations are performed to determine the concentration of an unknown solution. And this solution that you don't know the concentration of is known as the analyte. And in order to find it, you use a solution known as the standard that you know the concentration of, and you also know the initial volume of it. Here, our standard solution is NaOH, sodium hydroxide. And in this burette, we have measured an initial volume of 10 milliliters from the top, or all in all, I have 40 milliliters in this burette. Before we began, we primed this burette by cleansing it with water, and then we also put about 10 milliliters of the NaOH into the burette and swished it around and drained it. We did that 3 times to be sure that the entire burette was primed properly. In each of our trials, we're going to do 3 trials. In each of the trials, we have an indicator solution that allows us to see a change in color every time a drop is added. And so we continuously swirl it to make sure it's evenly distributed. And near the end of the experiment, like we are now, when the titration point should be reached, we slow it down so we can clearly wait for the distinct color change. We want it to turn a light pink. Here, as you see, the color change is now distinct. It's not disappearing when I swirl. Therefore, the titration point has been reached. And in order to complete the calculation, you'll use the formula of C1V1 equals C2V2. We know all of the information for C1V1 because now we're going to record the final volume that is in this burette, which is at 49.02 milliliters. And from that, you can find how much of the sodium hydroxide was put in this Erlenmeyer flask by subtracting volume final, 49.02, from 10 milliliters, which was our original. And that'll give you 39.02 milliliters in this flask. And when we want to go and find the concentration of this sample, we will use the C1V1 equals C2V2 equation.
Hello, my name is Angela Bird, and today we're going to talk about titrations. Titrations are performed to determine the concentration of a solution. Before we started today, we cleared out our burette, we primed it 3 times with the NaOH solution. Then we filled it up to 10 milliliters of NaOH solution. The next step, I'm going to take our unknown and we're going to perform the titration process. I'm going to release the NaOH into my unknown to determine our titration point. I'm waiting on my solution to turn a slight light pink, and it's going to stay light pink. Getting close. So I'm going to go a little slower. Right now, as you can see, we have reached the titration point. It has turned a slight light pink. I'm going to record my data, which was the initial volume, which was 10. The B final was 49.69.
Hey, my name is Melanie McDonald. Today we're doing titrating. Before we started, we primed the burette with 10 milliliters of NaOH in all 3 different times by switching it around in the burette and then releasing it back into the sink. Titrating is used to find the unknown concentration of a solution. We use the analyte, which is KHP, and the standard, which is the NaOH, to find initial volume is 10 milliliters. And then you start releasing this into the flask until it turns a slight pink color to find the concentration. And then let it go slower and then see how much it takes. But you can see it's turning a light pink, but it fades away because the concentration isn't full. But I'm going to slow it down some, switch it. The end point will make it turn a very slight pink color. But if it gets too dark, then the concentration is messed up. So you see that it's a slight pink, and the end point is red from the bottom up, which is at 49.50. Then you subtract that from the initial volume to get the actual volume of the solution, which is 39.50.